Hey everyone, welcome to Data 5610. This is kind of the first initial kickoff video just to get you somewhat familiarized with the course, how things are laid out, what we're trying to do this semester. I'll say at the start, Canvas will be your default go-to for any questions or things like that, but also feel free to reach out to me, email me anytime. I'm always happy to chat with you and also hope to meet you guys at some point either throughout the semester if I haven't met you or afterwards if I get a chance. But either way, let's jump right into it. I want to kind of formally introduce myself if you haven't taken a class with me. So my name is Sherrod Jones. I'm a professional practice assistant professor here at Utah State University. You can see my wife there in the picture, Dr. Carly Fox. Some of you might have taken a class from her or maybe get a chance to. She's also a professor in our department, teaches courses around kind of text analysis as well as some of our intro modern data analytics and other courses, and things might have been added since I mentioned this. But either way, so that's my background or what I'm doing now, a little bit on my background. So as you can see there, born in Germany, but for the most part grew up in Texas. Still have a lot of family over in Germany, but US for the most part of my life. I did my undergrad in Houston at Rice University in astronomy. Had a life crisis after that, trying to figure out where I should go, what I should do, what can I even do with my, astrophysics background. Ended up tripping and falling my way into, it's kind of listed out of order here weirdly. It's academic first and then my professional career, but chronologically after Rice University, I went to Carvana. If you're not familiar with them, they're just kind of a used car online retailer, kind of classic tech startup world. I was very fortunate to end up there in 2017 or 2014, sorry. That was a year after they had started, just a couple, probably 8 months or so after they had started. So still a very, very small team. It was maybe 30 or so of us. But I was the first data scientist on there. Not initially a data scientist, started out just doing kind of grunt work type stuff before transitioning into the data science role about 6 months into it. But yeah, I got to see kind of this hyper growth phase of a startup. Did a lot of machine learning, a lot of statistical analysis in that world up through that growth phase. Then after the IPO, after that kind of massive growth, I left and actually came back to school. So I did my PhD here at Utah State University in statistics. Throughout that time that I was still working, I started in 2017 at the university here, and then in 2018 went to Maxar. Maxar is a satellite imagery company. If you ever go to Google Earth, Google Maps, in the bottom right-hand corner, it's probably going to be a Maxar image or a digital globe image, which is a Maxar company. The company I was working for, technically Radiant Solutions, they were acquired by Maxar right as I started on. So it's still kind of a transitionary period, but we were focused exclusively on the analysis of that. So that's where I stepped into the computer vision world, was working on neural networks, all that sort of fun stuff. But that was kind of my first foray into that world. And that really led the rest of my career and academic pursuits after that point. So I did my PhD while I was working at Maxar still. So it was kind of done in congruence with it, worked really well. Awesome time, awesome people there. And then after that, I went to another small startup, StriveWorks. They're still fairly small, but they're a very niche focused group in the kind of government defense contracting space. That's again just a little bit about me. Outside of that, I have a lot of other things I'm working at the university. I'm a mentor in our Analytics Solutions Center, which if you haven't gotten a chance to see that, I recommend. Just Google Analytics Solutions Center, USU, and you can see all the details about that. But that's where I spend a good bit of my time. And I also work on some external efforts, advising various startups and doing all sorts of other fun things. You can see my dog there. He eats up a lot of my time as well. That's Miko. He'll probably make his way into a few other slides throughout this semester. But as I said before, too, please reach out as well if, you can. I'd love to get to know you all. I don't want the online course to be kind of this isolated world. I'd love to see you, meet you. We can hop on a Zoom call anytime. And yeah, that's just a little bit about me and hopefully contextualizes where I'll be coming from this semester. I'll inevitably draw on countless examples from my experiences here and things I've been working on recently, but just to let you see kind of that's where my kind of background and focus has been. Going on to kind of the course objectives, that first bullet point to me is kind of the key detail here. There are no secrets. There's no secret of what content's in this course. I'm going to outline kind of high level the bullet points of what topics I hope we hit this semester. I would be lying to you if I said this information did not exist online, right? YouTube has been around for many years. There's some amazing videos. There's some great online resources and tutorials and lecture videos. And so I don't want you to think that this is an isolated world. I actually encourage you to branch outside of just these videos. What I want you to look at me for is really anchoring the sequencing of this into something that I think is somewhat of a logical sequencing. I'm certainly here to help you on the assessment and evaluation of your understanding of these skill sets. But more importantly than anything, I'm here to help you and answer your questions, right? Like that is the unique piece that I hope to bring to you guys, is that as you have ideas, thoughts, concerns, paths you want to explore, like bring those ideas to me, right? That's why I keep hitting on that point. The core thing that we can do as data scientists, and I'll talk about this plenty, is figure out how to ask good questions. And so don't let this course be any different. As you have ideas or thoughts or wondering where connections exist, reach out to me. These videos are just a starting point for this. So please focus on that. And then the other piece of this, obviously, too, is building that portfolio out. I'm here to help you evaluate that, but so much of this course will be focused around you building really cool things that you can point to, right? I want you guys to walk away from this class when somebody asks you, hey, you mentioned you did advanced machine learning or deep learning. Tell me about that, right? What does that mean? I want you to be able to point to all the different projects, the things you worked on throughout this semester, and I want those to be unique to you, right? I don't want this to be just, hey, we all worked on the same exact data set and got to the same exact answer. My hope is that you all work on entirely different things this whole semester. Like, put the burden on me to grade a bunch of different things, but it's much more fun to see all the different unique ideas you guys can come up with. As far as overall course structure is, just a little bit of housekeeping. I'll be quick through this. About 14 modules this semester, plus or minus 1 or 2 if it changes. Feel free to recommend changes as well. If you're like, hey, I really want to see this topic, shoot me a message. I'll probably be interested in talking about it, and we can make another video on that. But yeah, 14 modules, roughly 2 lectures per week, right? So there'll be like day 1 will be a theory lecture. Day 2 is going to be some sort of hands-on or applied. It might change a bit, especially as we get towards the end of the semester, where even the methods get more complex. They actually get simpler to explain because you kind of can't get into the weeds too much on them anyway. So towards the end, it'll be a little bit more probably hands-on than anything, and we'll have some days where we're just kind of talking about a concept, but that's the idea. As I mentioned before, there'll be these mini projects. I'll have the dates on Canvas for them, but expect anywhere between, 4 to 6-ish. It changes each semester as I get new ideas and I pull ideas out of it, but it'll be roughly paced so that it's equivalent work no matter how you're approaching it. And yeah, these will be every few weeks. Like I said, they're going to be very open-ended with some guidance and structuring to kind of scope them, but really they're going to be for you to explore and play with as you want. Then after that, I'll kind of skip to the next bullet point after that and come back to the knowledge checks. But after the mini projects, at the very end, we'll have a final project, and that'll be completely self-guided. I put that out there now to say, start thinking about it. We'll have a check-in point about halfway through the semester, maybe 3/4 of the way through the semester, for some proposals on that, just so I can make sure that what you're hoping to do is actually within scope. But to be clear, that final project, I don't require that it is completed by the end of the semester. What I mean by that is there isn't really an end state of any data science or machine learning project. Everything can be extended further. What our goal is in this course is to come up with a really, again, interesting question to ask, and then find data that can help us start to answer that question. And then in this course, you'll be expected to complete a meaningful portion of that analysis that leverages skills you've learned in this class. And that will be evaluated then at the end based in that kind of scope, right? So if you get to the end and you're like, hey, I was trying to, build some really complicated computer vision application, and all I was able to do is bite off a little piece of it to show how I can take the first steps at understanding what's in this image, but I didn't get to this, and that's what's coming next, that'd be a perfectly fine outcome, right? I want these to be something that means something to you or something you'd like to continue on. For that matter as well, too, if you have, or you're working a job, or you're doing some side projects, if you want to align either the mini projects or your final project with that or with your company, I'm perfectly fine with that. I'm happy to make adaptations or adjustments. You can keep data private as necessary as well, too, if you're working for a company. But I actually heavily encourage them. And as you saw in my background, I was taking classes while working. And to me, that was the most valuable experience when I could be like, hey, this thing I'm doing in class, I'm going to do it for my work because I have such deep knowledge in that space, and I'll be able to really contextualize that. So certainly encouraged there. The grade breakdown, again, another one of those things that adjust slightly. Or actually, let me jump back to the knowledge checks really quick. The knowledge checks are a somewhat more recent addition. This is really to sit in place of kind of your standard summative assessment where I would give you guys an exam to say, hey, prove that you know this thing. I don't necessarily want you to feel like you need to memorize every detail or aspect of machine learning, of deep learning, in the sense of you can go complete an exam. What's actually more important to me is that you can speak about these concepts. Because when you get into an interview, the first thing they're going to ask you is, if you have, again, machine learning listed on your resume, is they're going to say, okay, tell me about it, right? They might ask you very specific questions. And especially as you move to the technical interview phase, you are going to be asked and be expected to have almost intuition about a lot of these concepts. And so that's what those knowledge checks are going to be for. They're going to really serve this space of, I want you to be able to, and I'm just going to give you guys a list of questions, basically. You'll see this, and I'll have more details when it gets to this end, but I'll give you a list of questions. You're going to pass those to the LLM. The LLM will then ask you those questions. You can do it as a voice mode if you want to. You can use ChatGPT, Gemini. I don't care about the details of that. What's really important is that you have this list of common questions that you'll be expected to know about a specific topic or a set of topics, and that you can meaningfully answer them. The nice thing about using the LLM, and one of the reasons I do it that way, is that you can say, hey, I don't really know, or can you explain this in a slightly different way? And that's more than okay. These will be graded on completion, not on accuracy. Though I will expect some level of effort. So you can't just say, I don't know, right? You have to have some effort. So I guess a combination between completion and effort will comprise the score. You're also welcome to reach out to me if you'd like to do it as kind of an oral exam or just an in-person or via Zoom interview with me. I'm happy to read the questions to you and basically act as the interviewer as well. This is just if you don't want to have to meet with me, and also to ensure that I don't have 50 people in my office trying to make that work. But I'm happy to meet with a handful of you if you guys want to as well. Do that in person. But yeah, as I said, Canvas will have the grade breakdown. Again, another thing that changes semester to semester, but you can expect that a good portion of it is given towards the final project. Then I'd say the next largest portion to the mini projects, and then after that will be the knowledge checks. And same deal for office hours. Those are adjusted semester by semester. So I'd say for the most accurate information, go check Canvas, see what's on there as far as when I'll be expected to be online for office hours, or also in my office here. You can come in person as well if you're in Logan. I would say more than anything, if you want to meet with me, just shoot me an email. I'm always happy to meet. That's my job. Like I said, that's what I like to do, meet with you guys, talk to you one-on-one. So you're welcome to email me anytime, just sherrod.jones@usu.edu. Set up a time and we can come and chat. And that way you don't even have to worry about waiting, because with Zoom office hours especially, I just have to leave everybody in the waiting room as I get through each person. So that's a little bit easier sometimes. Okay, so on to resources. No required texts or anything for this class. I just wanted to provide these as extra resources if you prefer books. I like to have a textbook to go back to at least, again, get the logical order and sequencing of things. The first book that's listed there, the deeplearningbook.org, that's a little bit more of a technical text. It's freely available online. It's a PDF that you can access. Some pretty famous authors wrote this book, and that's a good one if you're like, hey, I'm getting a lot of the programming side. I kind of understand that, but I want a lot more of the theory side. I really want to understand, how do we get to this point? What's the math behind this? We'll obviously hit a lot of the math in this class, but the real kind of deep, analysis and derivations of where a lot of these things come from, those are captured well in that book. It also has a really nice opening section that gives a lot of the background mathematics that build up to the machine learning part. So if you're like, hey, I've been out of it for a while and I really want to kind of brush up or be reminded again on what some of the math backing this is, you're welcome to go there. Again, to be clear, if you've taken 5600, Data 5600, or an equivalent course, you'll have sufficient math to do this class. It's just there, again, I always like to point people towards resources that kind of go beyond the scope of the course. The second book there it's near and dear to my heart, I'll say. This is the book I picked up, kind of the first edition. They might even be on to a third edition, I don't know. But the first edition was the one I picked up when I got that job at Maxar, and I had maybe one machine learning course, if anything, at that point, but definitely not any deep learning experience. And as we're going to do a lot of deep learning in this course, that'll be more relevant. But for me, it was, hey, I have a couple days to brush up on and figure out what this whole deep learning thing is, so I can at least stand a chance at my internship, which then became my full-time job in 2018, 2019-ish. And so that book is really good. That is code first by far, where the other one was math first. This one is 100% code first. We'll actually use a lot of examples from that book as well in this course. I just really like it. I think it's a nice, simple, easy to understand framework or textbook that uses a framework that is a lot easier in these learning phases. It might not be the most flexible in long term, but I think once you understand the basics, it's so much easier to adapt. And the third one there is another online book resource that a different professor I had used that I thought was a good resource, especially if you're coming from more of an engineering background or computer science background. That one's a nice text as well. So those are all just different resources there. Compute-wise, no need to have a fancy computer. We'll obviously be doing things that are very compute intensive, but we'll be leveraging for the most part Google Colab because they have free GPU resources, but we'll have access to plenty of other cloud tools as necessary. And if there's ever anything like on the final project where you're starting to push beyond the scope of what's available in Google, then I'm always happy to help you access more resources, via AWS or something like that. So yeah, like I said, long list of things that we will almost certainly cover, or we'll cover all these bullet points. There's a few other things that I'd like to touch on if we have time. But as I said before, if there's ever any topic where you're like, hey, I've heard about this thing, or I just saw a news story, feel free to send it to me. I'm happy to either talk to you about it one-on-one, or if it's kind of a big enough scope, right? If something changes dramatically in this field, which can happen sometimes, I'll probably add that in there as well too. But you're always welcome to reach out to me with ideas or thoughts of where you'd like to go. Just to connect this then with kind of the data 5600 side of things, right? So if you took data 5600 here at USU, you'd spent a lot of time getting deep regression analysis, right? You'll have a broad understanding of that field, and that is absolutely foundational for everything we're going to be doing. We're going to start out this semester in the kind of supervised learning, structured data space, and then we're going to be moving down towards deep learning probably about third of the way through this semester. We'll get into deep learning, and then the rest of the semester will be kind of all in this deep learning world. But I like this plot because it kind of, and I guess I can slide myself out of the way too over here if you're kind of blocked by that. I like the layout of this of saying, hey, we have flexibility on one axis and interpretability on another axis. It's not perfect, and it's not 100% accurate in all scenarios because those are both very loosely defined terms of flexibility and interpretability. What we typically mean by that is more flexible a model is, the more capable it is of learning abstract representations, more abstract representations. That is the strength of deep learning. That's what we'll spend a lot of time talking about, is that deep learning has this capability of learning very complex relationships. Therefore, it is very flexible, but that usually and almost always comes at the expense of interpretability. There are few methods that are easy to interpret and are very flexible. Actually, I don't think there's anything I can think of that is exactly that, right? There are certain use cases or situations where something might be a little bit more interpretable, or there might be a piece of it that's interpretable, but usually there is this relationship. And so recognize that as you're transitioning from 5600 to 5610, is that we're progressing down this plot kind of in this negative association. That's not to say that one is better than the other, though. And that's, again, this goes back to this idea of what our role as the data scientist will be. It is to understand kind of the lay of the land. There are problems, many problems, where you need to be up in this realm of interpretability first and above all else. And there are other problems where, hey, we can scrap interpretability, we just need performance. And then you can start to move down to this side. And then there's this nice spectrum in between. And so recognizing the capabilities of these different techniques and where their strengths and weaknesses are is going to be critical, and a critical piece of being a data scientist in this era. So moving on, I want to address kind of a big bullet point for this, and that is that you're going to start, especially as you're in this field, you're going to start getting asked a lot about AI. This is something that didn't used to be as common of an issue. I don't even want to say it's an issue, but it is something that it's worth having the right vocabulary around. And that's really going to be my goal, especially early on in the semester, is get you the right vocabulary of how to speak about these things. The world of large language models has changed the space dramatically in the last few years. Prior to, ChatGPT late 2022, people were aware that machine learning existed, and they were aware that data science existed, but it existed as this ephemeral kind of idea. And then ChatGPT came, and all of a sudden everybody was like, oh man, I think I kind of get the power and capability that is enabled by machine learning, by deep learning. The downside, or kind of the counterpoint to that, was everybody started to view everything that you do in machine learning as being large language models. And so it's really important to get the right vocabulary to be able to explain to people which situations are we using large language models, and what situations are we using convolutional neural networks, what situations are we using kind of classic supervised learning techniques like random forests, and why would we do that, right? What are the strengths and weaknesses of all? And so I usually use this slide in my talks that I give on AI to kind of highlight this differentiation. First off, that there is this world of artificial general intelligence that is the theoretical future sentient robot that can learn and understand and adapt at least as well as we do as humans, if not better, in any scenario. I don't worry about that. There's nothing to suggest we are at that point or near that point. It's completely opinion based. Every scientist has different opinions on where we at regarding AGI. So ignore that for now. Let's focus on this narrow intelligence bucket, which is where we're at now. These are things that are designed to do one task and do that task well. That might mean that they orchestrate multiple different things, right? There might be one model that's really good at knowing when to select a different model, and therefore it selects a different model, at which point that model can do its very specific thing, right? So there's this orchestration, this almost meta learning aspect that can exist. But fundamentally at their core, they're trained towards a target. Large language models, right, they would fall inside of this deep learning bucket. Artificial narrow intelligence is a broader bucket. Anything that learns at least as well as we do in one specific area, that'd be a narrow intelligence model. Machine learning is a subfield of that. A subfield of machine learning is deep learning, that's focused on neural networks. And a subfield of that is large language models. And so they are certainly a form of AI by definition, but they are not all of it. And so our job is to, again, be the experts in the room that can help clarify that to those others that we're working with, right? So keep that in mind. That's just a bit of housekeeping vocabulary to get us through this, but I think it's a really, really important detail. We'll be focused almost exclusively this semester as well in supervised learning. And it's not to say unsupervised learning isn't valuable, and actually there's another field of semi-supervised learning that I use a non-zero amount of the time. But supervised learning really captures so much of what we do that it's important to recognize its role in this space. What I'll say is I try to keep these 3 bullet points in mind, again, especially from a communication standpoint. Your job, again, as a data scientist is not just to do the thing, but also to be able to communicate what you're doing and how you can do things and what you can do. And so whenever somebody asks me or presents me a new problem and says, hey, can I use machine learning to do X, or can I use AI to do Y? The 3 things I ask them is, what data is going in? What is coming out, right? What are you trying to output? And then how are you evaluating the quality? If they can answer those 3 questions, and even better if they have data to support those 3 questions, then it's a classic machine learning problem. It's not to say it's solvable. I can't guarantee it's solvable, but I can guarantee that I can apply machine learning to that and I see kind of what capabilities exist today given your data. But those are kind of the 3 bullet points, because then that's also the research path around applying these machine learning models, right? Is I collect good input data, I ensure that I have a good associated labeled outputs, and then I ensure that I have the right and robust measure of quality for my model. So again, that's really what we're looking for in this machine learning space. So I want to kind of end this at least intro video on just a little bit of the why we're doing this. And again, in this world of AI, I mean, you guys have probably already tried this, right? You can go into ChatGPT, take a data set, throw it at it and say, solve my problem. So what role does the data scientist play? What role does machine learning play in this? I used to, and I still do to some extent, we'll see why, but I used to point to Bloom's taxonomy as a really good example of this. If you're not familiar with it, Bloom's taxonomy is a model, a framework for how we understand knowledge acquisition in humans. It used to hang on the wall of my elementary school classroom. That's why I always reference it. I would see this rainbow pyramid every day. But it's a nice model, right? With some caveats, but it's a nice model in that, there's this idea that memorization and memory in general is kind of the foundation of learning, right? Being able to remember those things, recall those things. And then from there, we build up this ability to understand, and we can apply those things that we understand, then analyze them, finally evaluate. And the pinnacle of knowledge acquisition in this framework is creation. And so early on in this ChatGPT era, I'd point to this as saying, hey, if we think about it this way, right, we can kind of continue to proceed up Bloom's taxonomy, right? The role of the human is to capture that high level creation, that novel creation aspect of this. And, computers are getting better, already great at remembering things and getting better and better every day at each piece up this ladder. But our role is going to kind of sit at the top of this pyramid. Then not too long ago, Anthropic released and I'll slide myself out of the way again, Anthropic released a really interesting educational report. They also have a nice economic report. You can just search Anthropic education report, Anthropic economic report, and you'll get the links or just pull them up on Canvas from Canvas. But from the educational report, they looked at students, or at least their expectation of people using Claude, one LLM tool, using Claude for learning, right? So they tried to identify cases where they thought people were using it in an academic scenario, and they said what percentage of the tasks they did fell into the different categories of Bloom's taxonomy. Again, caveats with anything else with any research, but I think it still sends an interesting message. And I'm sure you guys can see it now that it is an inverted pyramid for the most part, right? Is that people aren't really using large language models for memory, which is not too surprising. If you're going to recall a specific fact, please just Google it and then look up the information. But you don't really see people doing that here. You actually don't see them doing much understanding or even application. It really starts to pick up actually in this analysis and especially in the creation phase, right? Which in hindsight to me makes a lot of sense. How many times has somebody gone in and said like, help me do X, Y, and Z, right? Help me create an outline for this, or help me write up an essay for that. Again, take it with a grain of salt. I have differing opinions on what I believe creating something new means, and I will talk plenty about that as we get to the kind of the generative models aspect of this course or module in this course. I would argue it's not actually in true creation, but fundamentally the message still stands. But to me, the really, really interesting piece is this little bottleneck right in here is the fact that we don't often use, at least given this data, large language models for evaluation. And actually, intuitively, it kind of feels right? Every time I use ChatGPT or Gemini or whatever, Claude, I'm asking it to do something for me or help me understand something. But then there is a phase of this where I say, I'm going to take this now and use it in the real world. Right? I'm either going to act upon it, or I'm going to start writing the code because I think, or I'm going to copy and paste the code in if I'm just copying it over, right? But each of those things, the choice of doing that is an evaluation, it's a judgment call. And so it's not too surprising that we see people don't use it for evaluation in that sense, right? There are some things we may do, but fundamentally we don't really use it for that. And so that to me highlights just this possibly valuable opportunity here, is that it might not be that we have this retreat up Bloom's taxonomy, and we might not be trying to find our place as creators or finding our place as memory machines, but really like our role kind of always exists in this evaluation phase, right? We are always still making the decision of where do we apply this in our lives. And so that is exactly the same as if I'm a data scientist, right? I'm still operating and acting as a data scientist in many capacities. I work on a lot of different projects via the ASC or with the partner companies I have. And so in those cases, I still do my data science task. I still generate code and I generate analyses. But at the end of the day, my job is to evaluate when it actually is a meaningful improvement or it actually does what I need it to do. And so that's going to be your goal in this course, right? The goal is not to now necessarily just be kind of this code generation machine, right? You don't have to be. We know we can generate code, we can generate models. And actually the code for building machine learning models is often wildly simple. The real hard part is figuring out what question to ask and why we need to ask that. What tools do we even have at our disposal? Because while I can certainly ask ChatGPT, how do I know? How do I evaluate that it picked the right thing to do at the right time? How do I ensure that I'm actually exhausting all possible options in the space and exploring interesting new ways to apply or bring pieces together? So we really need to learn these almost generalizable skills so that we can apply them and then evaluate our outputs, right? And so again, your job as a data scientist is going to be a problem solver via data. That's all it ever will be. Given data, solve problems and ask questions. And so we're going to really focus on those skills and try to build that up. And kind of the last bullet point I'll put on this is that a critical piece that's often missing in our technical courses is the dismissal of domain expertise. It's kind of the classic joke that data scientists and computer scientists will walk into a room and say, I'm going to solve your problem, right? Or I can solve your problem via machine learning. And then you start looking at their problem, you start to understand, you realize, actually, this problem is really hard. I don't think I can solve this. I'm going to go on to the next thing, right? So we don't want to fall into that trope. And actually, more than that, We want to prove our value. We want to prove where we differentiate our value. And the biggest way you can do that is to really understand a domain. Because as you understand the domain, you understand the limitations, the problems, the open questions, and then can pose them in the context of data and ideally solve them, right? Or at least provide a reasonable next step. It's something I didn't recognize of in my career, but fundamentally, right, I had undergraduate degree in astronomy, so did a lot of actual imaging and physics to underlie that. And then I went on to work at Carvana, which wasn't just by chance. I'm actually a super big car nerd, so if you ever want to talk cars in any capacity, that's something you can get me ranting on for a while. So I was doing data science, but it's in the context of cars. And then to go back to the astronomy side of things, when I got the job at Maxar, Maxar is a satellite imagery company. So I've been working with satellites actually explicitly when I was in my astronomy program, because we use things like the Hubble Space Telescope. But even more so, I understood a lot about the kind of space domain. And even though the cameras were flipped, kind of pointing down at Earth as opposed to out to space, they're fundamentally using the same properties to take that image and same techniques and tools to analyze those images. And so I had that domain expertise, and now I was just applying it in the context of machine learning. And every story since then, every project I've done since then, is the ones I've been successful in, at least, are the ones that I really understand the problem. And the ones that I usually fail or struggle in are those that I really didn't take the time to dive deep on that industry. And so it's just to say, don't expect to be kind of this jack of all trades here. We're going to just learn the right skills and right tools, and then we're going to apply them to interesting and meaningful problems. So I'll leave it at that. We'll pick up next time and start to get a little bit more in the weeds on how to actually do some of this stuff. But like I said, excited for you guys in this course. Really excited you're starting this journey. Could not be a better time to jump into this space. It's so fast moving, and that is a good thing. It's constantly evolving. There's constantly new things to learn and build into. The job you want in the future likely does not exist now. Me going into data science in 2014, it did not look the same then as it does now. The jobs are entirely different. And so that's all we're trying to do, is really just give you the skills to solve those problems. Okay, so catch you next time. Reach out if you have any questions. Thank you. Bye.